Hello students, welcome to today's statistics class. I hope all of you are safe. Now today's class is going to be called as Bridge Course class. What is it? Bridge Course class. Now you may be wondering what is this new name, isn't it? See, the thing is actually all of you are aware of the concept that we had only reduced syllabus both for first PUC as well as for second PUC. Now you children, whoever are in first PU, you had a few chapters in which 2 chapters were reduced. In other words, you say 2 chapters were not taught for you in the reduced syllabus. So those 2 chapters which were not reduced, one was probability, okay? Another one was, so you call it as mathematical expectation, right? Now the thing is, this probability chapter forms a basis for quite a lot of concepts in statistics. And actually, there is one chapter called theoretical probability distribution in second PUC. So if at all you have to do the problems in the theoretical distribution, you must be aware of this probability concepts. So that is the reason. Now today I will be teaching you a few concepts, or say briefly, okay? Very briefly, I will be teaching you this concepts in probability, now which will become very, very useful for you to study the second year PUC theoretical probability distribution. Okay, fine? Now, the thing is, in both this mathematical expectation, right? Now, this in turn depends upon the probability. So, both of them more or less they are linked, right? So, first of all, we will do everything in probability. Based on that, whatever is required in mathematical expectation, that is also will be solved for you people. Okay? Now, before I start exactly with the probability chapter, the first concept is you have more of definitions. So, in other words, you say, if at all I have to define the definition of probability, I have to have some more definitions. In each of the definition, we will be giving you one example. Understood? You remember? I myself had taught you this basic concepts in first PUC. So if you remember, so in all the definitions, if you are able to give an example, with the help of an example, it becomes very, very easy for you to understand the definition. Now normally we suggest you not to mug up or memorize the definition. Please try to understand. So when you are understanding, this examples becomes very important. So therefore, in all the definitions which we are going to do in probability, there are more or less 3 to 4 examples. So first I'll tell you what are those examples. After that we'll come to definitions. After that we'll come to the probability chapter. Hope it is clear? Okay. Now all of you are aware of this coin, right? Coin. How many sides this coin has? 2 sides, right? One is on the one side, first side you have head, on the other side you have tail. Okay. Now these two will be, this concept of coin will be used whenever I am using the definition. This is the first example. In the second example, the same coin, instead of having one coin, you may have the concept of 2 coins. The third one, you have heard about die, right? All of you? So die, or you say, okay? Now something like this you have. Now, it has 6 sides. On each of the side, one number will be there. So this die will have the number 1 on one side, number 2, 3, 4, 5, 6. Okay. Now, one single die will have these 6 outcomes. Each number will be written on one side. Now, suppose you are having 2, then you call it as 2 dice. Right? Okay. Now, the next one you have what are called as the cards. So, these are called as actually playing cards. Okay. You people are students, right? So, we will be using this in terms of playing cards. Of course, in the playing cards, you have different type of sets, different colors are also there. So, all of you are aware of the fact that in the pack of cards, there are about 52 cards, right? So, there are about 52 cards, and these 52 cards are divided into 2 colors. One is red, another one is black. Now, that means how many red cards will be there? There will be 26 red cards. There will be 26 black cards. Altogether, you will have 52. Now, other than that, in the red cards, you have 2 different sets. Okay. So the red cards has 26 red cards are there. Out of this there are 13 what? Diamond cards. Okay, now something like this. Okay, other one is, of course, all of you are very familiar with this, right? Heart cards. Okay. So the next you have the 26 what? Black cards. Again in this you have 13 and 13. So 13 club cards are there. So it is something like this, right? Or you call it as clover. Now the other one is club cards. This is something like this, right? Now okay, 1 minute wait, let us not. Okay, I would make it very simple. The other one is you have the leaf cards. So this is how you have. Now why am I giving you all this is, when we start solving the problems, you must be remembering now. How many cards are there, total number? How many red cards are there? How many black cards are there? How many diamond cards are there? How many club cards are there? How many leaf cards are there? So all the definitions will be surrounding in and around these examples. So is it clear? If you want, you can just make a note of it, right? Okay. So before we actually define the term probability, as I told you, you have a few definitions. So one by one I'll write it down and explain to you. So the first definition is called experiment. So experiment means it is nothing to do with any lab or anything like that. Okay, it may be a game or a process. So you say an experiment is nothing but a process which gives rise to, or which gives yields also, you can say, which gives rise to a definite result. See, I'll read it out once again. So experiment is nothing but a process which gives rise to a definite result. So when you perform an experiment, now it should give rise to a result. Now what does this result mean? So the result is nothing but an outcome of the experiment. So when you write an exam, that is also one experiment. So you will get your result. You may get a first class, you may get a distinction, isn't it? So therefore here also it is the same way. So result is nothing but the outcome. Now in this experiment now we have two types. So in other words, you say the experiment is classified into two types. One is called deterministic experiment. Another one is called random experiment. Right? So an experiment is classified into two types. So first one deterministic experiment, another one is random experiment. Now what is the difference between the two? Suppose you are performing an experiment under the same identical condition several times. Okay. So if you are repeating the experiment under the same condition several times, and if that experiment gives rise to the same result, right? So it gives rise to the same result any number of times you perform the experiment, but it gives you only the same result, right? If that is the case, you call it as deterministic experiment. Okay. On the other hand, if it does not give rise to the same result, it gives different result. Okay. So it is not same. So it gives rise to different result. Then you call it as random experiment. So I hope you have understood. So what is deterministic experiment? An experiment when it is performed several times under the same condition. If it gives rise to the same result, you call it as deterministic experiment. On the other hand, if it gives rise to a different result, not the same result, then you call it as random experiment. So in the probability chapter, we will be more or less considering only the random experiment. Understood? Okay. So this is all about your experiment. Okay. So the next definition, this is the first one I have written experiment. Next you have random experiment, the third definition. Okay. Now this is called the sample space. Now obviously I told you, whenever you perform an experiment, you always get a result. That result is called an outcome. So sample space refers to the set of all possible outcomes. Okay. So the set of all possible outcomes of a random experiment is called sample space. Understood? So the set of all possible outcomes of a random experiment is called sample space. Now usually the sample space is denoted by S. Now in your high school you have learned about the sets, isn't it? So the same way here also this sample space is nothing but a set. So therefore you will be representing this by means of two flower bracket. Okay. Now we will be starting with our example. Now let us assume that one coin is tossed. So this you say one coin, or you say single coin is tossed. So what are the outcomes you have? So one is head, another one is tail. So if I put both together, so then it becomes sample space. So when a single coin is tossed, there are only two possible outcomes. One is head, another one is tail. So therefore S is H and T. This is when one coin is tossed. Okay, fine. Now suppose we extend this to two coins. Now let us assume that there are two coins and we toss all the two coins together simultaneously. That is at the same time you toss both the coins together. Then what are the possible outcomes? So first coin will show head, second also may show head. All of you are able to understand? Otherwise, the first coin may show tail, second one will show tail. Now another possibility, first one will show head, second one will show tail. Next, first one will show tail, second one will show head. So these are the four possible outcomes. So in this case, so you will write now S is equal to H, H, T, T, H, T, T, H. H is for head, T is for tail. Okay. Now you will have to remember, when one coin is tossed, it is one coin. One coin has how many sides? Two sides. So therefore the number of outcomes here will become 2 to the power of 1. It will be 2. Okay. Now in this case, what happens is two coins are tossed. Each of the coin has how many sides? Two sides. So therefore it will become, the number of outcomes will be now 2 to the power of 2. So it, in other words, it will become 4. Now if you take 3 coins, okay. So how many coins? 3 coins. Each coin has how many sides? 2. So therefore the number of outcomes will become 8. So in the due course I will be writing that sample space also. Now this is all about your coin. Suppose you may wondering, suppose we toss a die. Okay. How many sides are there? 6 sides. Each side has one number. So S will become now 1, 2, 3, 4, 5, 6. Now this will become the sample space when a single die is tossed. I hope it's clear. Okay. Now next we have now what is called as event. Okay. Now event is set of outcomes of a random experiment. So what is it? Event refers to a set of outcomes of a random experiment. Now I have already written the sample space. Now you see here. So H is one outcome. So it is called one event because there is only one outcome. Now you call this outcome as a simple event. So one single outcome is there, therefore you call this as simple event. On the other hand, if you take here, this whole thing is of course this whole thing together will become one event. But in this one event, you have two outcomes. So, two put together. So, therefore, this is just called one event. So, an event of getting two heads together. Now, this you call it as event of getting two tails together. Now, this one you call it as getting an event of getting one head and one tail together. Now, whereas you take here, you say that this is, it can be taken as outcome because only one is there. So, you can be taken as outcome or you can call it as event. So, you say that an event of getting a head. Here you say an event of getting a tail. Now, this event is denoted by the alphabets A, B, C or anything. For example, if I want to represent this, now what do I do now? I'll write it as, so when one coin is tossed, so A becomes the event of getting head, or you say B becomes the event of getting tail. So this is how you have to represent with flower bracket. Now suppose you want to represent these events. So you say when two coins are tossed together, A may be the event of getting two heads together, B may be the events of getting two tails together, or C may be the event of getting one head and one tail. Or you can take the reverse way also, one tail and one head. However you want, you can write it down. So is it clear? Okay, fine. So next you have what are called as favorable outcomes. Now, favorable outcomes are those outcomes which help in the occurrence of the event, or you say happening also, no problem, which help in the occurrence of an event. So I'll read it out. So favorable outcomes are those outcomes which help in the occurrence of an event. Now say for example, we took this, right? S is equal to HH, TT, HT, TH. Now you see here, suppose you want to find out how many times you can have this event of getting two heads. There is only one possibility. So you say the number of favorable outcomes to get this event of two heads together is only one. So similarly, if you want the event of getting two tails together, how many possibilities are there? Only one possibility. So you say the number of favorable outcomes is one. On the other hand, suppose you want to find out the event of getting one head and one tail. In any order it may be. One coin is showing head, another coin is showing tail. If that is the case, there are two possibilities. One is HT, another one is TH. So in other words, you say the number of favorable outcomes for the occurrence of this event, one head, one tail is 2. This is how you have to remember. Okay. Now, the next one you have what are called as exhaustive outcomes. So, next definition, exhaustive outcomes. Now, see, exhaustive outcomes are nothing but the total number of outcomes. The total number of outcomes in the sample space of the random experiment. So you have the random experiment. So simply write down the sample space. Count how many number of outcomes are there. The total will become the exhaustive outcomes. So the total number of outcomes in the sample space of the random experiment. So the same thing I have to repeat now. Or we'll take the die experiment. Suppose say one die is tossed. How many outcomes are there? So S will become now 1, 2, 3, 4, 5, 6. So the number of exhaustive outcomes will become now 6. Now the previous one I told you, right? So when one coin is tossed, you have, So altogether 2 exhaustive outcomes. When 2 coins are tossed, altogether you will have 4 outcomes. When 3 coins are tossed, altogether you will be having 8 outcomes. So in the same way you can go on extending 2 power 4, 2 power 5 and all. So this 2 power 4, 2 power 5 and all you will be learning in your second year PUC class. Okay. Okay. Now the next one you have what are called as equally likely or you call them as equiprobable events. Now according to the concept you may be using this also, events, or you call it as outcomes. No harm in that. Okay. Now let us assume that you have 2 or 3 events. Now or outcomes also you can say. So these outcomes or events are said to be equally likely if they have the same chance to occur. Now same chance to occur. This chance, remember, that is nothing but your probability you say. So for example, you take a die. So I told you, now there are how many sides now? 6 sides are there. So this is 1, this number will be there, here 2 will be there, here 3, like that. I am not able to write it properly. So one side you will have one number. So that means every number is written only once. So therefore 1 is appearing only on one side, 2 is appearing on only one side. So therefore 1 has same chance to occur as that of 2. Now on the other hand, suppose here you have number 1 on one side, you have number both 1 and 2 on one side, another one you have 3. So here what happens is, now 1 is appearing on 2 sides, it has more chance to occur. So this will not become equally likely. So therefore here you say, whenever a die is tossed, each number is appearing only one side. Therefore it has, all the numbers have the same chance to occur. So same way, one coin is taken. So one side you have head, another side you have tail. So that means to say that both head and tail will have the same chance to occur. So therefore head and tail are equally likely outcomes. Okay. Now the next definition says mutually exclusive outcomes, or you say mutually exclusive events. Mutually exclusive events, or you call them as outcomes. Okay. Now if 2 events are there, then the 2 events are said to be mutually exclusive if one occurs and the other is not possible to occur. So it means that suppose one event occurs, then the other event cannot occur. So you say 2 events are said to be mutually exclusive if both of them cannot occur at the same time. So if both of them cannot occur at the same time. So if you take a coin, so as I told you, one side you have head, another side you have tail. So if you toss a coin, you may get only one outcome. It can be head or it can be tail. Both are not possible. Understood? So same way, when you toss a die, you may get either number 1 or number 2 or any of the 6 numbers. Now it is not possible to get 3 numbers at the same side. So this is what you say. Now to give you a very simple example. See, now what I am doing, I am teaching. That means I am talking, I am writing. So both things I am doing at the same time. So therefore, this is not mutually exclusive. On the other hand, suppose I am not talking, I am just writing. Then I am not talking. So that will become mutually exclusive. Understood? So if you say 2 events cannot occur at the same time, then you call that as mutually exclusive. So if you have understood these concepts, now we can write down the definition of probability. Now two more events are there. One is called union and intersection. So that as and when the problem comes, I will teach you that one. Okay. Now this term probability is defined in 3 different ways. Okay. Now the first definition is called classical definition. Fine. The second one is called statistical definition or empirical definition. The third one, now this is called axiomatic definition. Now we'll just start with the classical definition. Now this classical definition, sometimes it is called as a priori definition. That means prior to these two, you had the first definition. So it is called classical definition. Okay. Now what does this tell you? Now let us assume that there is a random experiment. This random experiment results in, say, n exhaustive outcomes. So what is that n as exhaustive? I told you, when you collect all the outcomes together and write the sample space, the total number is exhaustive. So let us assume that there is a random experiment and if it results in n exhaustive outcomes. Now let A be an event of the random experiment. So in order to occur this event A, let us assume that out of n, m of them are favoring. Okay. Now you see, S is what? Sample space. How many outcomes it has? N. Let us assume that A is one event. Okay. Now out of n, m of them are favoring to this event A. Then the probability of event A. Okay. This is denoted like this. See. So P of A. How will you read this? So probability of the occurrence of event A. Now this is denoted like this. So the total number of, or you say number of favorable outcomes divided by total number of, or you say number of exhaustive outcomes. So I shall repeat. So the probability of event A is P of A equal to number of favorable outcomes divided by number of exhaustive outcomes. So you will write it as P of A is equal to m divided by n. Now this is the formula that you will be using in future for all the probability chapter. Okay. So you say m divided by n. Now just to illustrate this with an help of an example. Now let us assume that two coins are tossed together. So how many outcomes you had? 4. HH, TT, HT, TH. Now let me try to find out this. Now what is the probability of getting event HH? So the question will be something like this. So when let two coins be tossed together, then find the probability of getting two heads together. So you will write the sample space. That means this will give you the exhaustive. So this is what you say n. How many are there? 4. So you will write it as n is equal to 4. Now here A. This is the event of getting two heads. How many possibilities? Only one possibility out of 4. So therefore you will write it as m equal to 1. So P of A. This is what you want. Now probability of getting two heads together. Number of favorable outcomes by number of exhaustive, m divided by n. So you will write this as 1 divided by 4. Now this will be your final answer. So understood? Now suppose on the other hand, you want say B, event of getting one head and one tail. So B will become now HT, TH. Okay. So what will be probability of B? How many possibilities are there? 2. 2 favorable outcomes. So m will become now 2. So therefore this will become now 2 divided by 4. Of course you can simplify that further. Okay. I hope it's clear. Now if you want, we can have one more example. Now let us assume that a die is tossed once. So the question will be something like this. So if a single die is tossed, or you say a die only, okay. If a die is tossed once, what is the probability of getting you can have like this, see, first part, number 3. Second one, you can have a number which is multiple of 2. Okay. So next, if you want, you can have an odd number. You can have, say, an even number. Okay, you can have a number which is divisible by 3. Okay, and read it out. See, if a die is tossed once, what is the probability of getting number 3? A number which is a multiple of 2. Next, an odd number, an even number, a number which is divisible by 3. Now, just write on the sample space. So, 1, 2, 3, 4, 5, 6, right? I will come to the first one. You want only number 3. So, you will say A is what? Getting the number 3. Fine. How many possibilities are there? Only one possibility. Here, what is n? N is equal to 6. How many times you can have 3? Only once. So, m is equal to now 1. So, probability of A will become now 1 m by n. This will be 1 by 3. Answer. Okay. Now, you take the second one. Number which is multiple of 2. So, which are the numbers which are multiple of 2? So, 2 1s are 2, 2 2s are 4, 2 3s are 6, right? So, what are those numbers now? Multiple of 2 means you can have event B, right? So, you can have 2, you can have 4, you can have 6. So, how many possibilities? 3. So, m divided by n. Okay. So, you will write it as P of B, m by n. So, 3 out of how many? 3 by 6. Now, this is your answer. This is your answer for this. Next one, odd number. So, what are the odd numbers you have? See, you can take 1, 3, 5. So, obviously, same thing, you will write m by n. The answer will become again 3 by 6. Okay. Now, take even number. So, it is which are the even numbers you have? So, 2, 4, 6. Again, this will come to 3 by 6. Now, next you have a number which is divisible by 3. Which are the numbers which are divisible by 3? 3 only, 3 by itself. Another one, 4 is not possible. That means you should not have a, you should have a, this one, what do you say? The remainder should be 0. So, 3 and then 6. Fine. So, if you take here, so this will be m by n. Again, you have 2 out of 6. So, this will become now 2 divided by 6. I hope it is clear.